we can construct a confidence interval to estimate a population proportion. For example, we can find what proportion of adults have a certain disease. To start, let's define some terms. We define P as the proportion we want to study. This is the proportion of successes in the population. The proportion of failures is Q, which is 1 minus P. Be sure not to equate success and failure with good and bad. In our example, having the disease is considered a success. As usual, let n be the sample size and alpha be the significance level. Let x be the number of successes in the sample. Then p prime, the proportion of success in the sample, is x over n. With p prime, we can define q prime, the proportion of failures in the sample, as 1 minus p prime. All confidence interval estimates consist of a point estimate plus or minus a margin of error. For a population proportion, the point estimate is p prime and the margin of error is the product of the z-score that corresponds to the confidence level and the sample standard deviation, which is the square root of p prime times q prime divided by n. There are two requirements that need to be satisfied in order to create a confidence interval for a proportion. The first requirement is that there must be more than 5 successes. This means that the product of p prime and n must be greater than 5. The second requirement is that there must be more than 5 failures. So, the product of q prime and n is greater than 5. If both are met, we can use the binomial distribution to construct a confidence interval estimate of the proportion. Now, let's try a problem that involves creating a confidence interval for a proportion. A company manufactures cameras for smartphones. One customer requires that no more than 3% of the cameras be defective. Out of a sample of 1,000 cameras, 27 are found to be defective. Find a 95% confidence interval for the proportion of defective cameras. First, we must check to make sure the two requirements are met. Note that in this case, a success is a defective camera. Check the number of successes. There are 27 successes, which is greater than 5. Next, check the number of failures. 1,000 minus 27 equals 973 failures, which is greater than 5. Since both requirements are met, we can construct a confidence interval. In this problem, x equals 27 and n equals 1,000. So, p prime is 27 over 1,000, or 0.027. This means that q prime is 1 minus 0.027, or 0.973. For a 95% confidence interval, alpha equals 0.05, and the z-score for alpha over 2 is 1.96. Now calculate the confidence interval. Substitute the appropriate values and simplify, rounding to 4 decimal places. The confidence interval is 0.0170 is less than p, which is less than 0.0370. We can say with 95% confidence that the interval between 1.7% and 3.7% contains the true proportion of defective cameras. Since this interval contains values greater than 3%, we cannot conclude that the proportion of defective cameras is 3% or less.